Hello guys, how are you doing? Can you all hear me? Okay, I think that's fine. I'm seeing myself. How was the contest today, guys? I managed to solve 4 problems today. I'm great. Okay, today we're gonna solve all of the problems, and we somehow have a new format. I came up with some ideas in order to improve the quality of the streams. For example, I'm gonna explain on iPad. In here I'm gonna explain. I have another scene, and so I think this way everything will be more clear. I also have this screen. And okay, so let's see how it's gonna go. Okay, shall we start talking about the problems? Yes, it was about finding the bridges. That was the main part of it. Yeah. Okay, so can you see my screen here? Oh no, you just see an empty screen. Let me change this. Okay, now you can see my screen, I guess. Right? Okay. So let's start talking about the problems one by one. First, let's talk about problem A. I think again, like always, we can first solve the easiest problems very fast because they didn't have any hard ideas. So let's go to contests. Problem A. Okay, problem A says that you are given 3 points with integer coordinates x1, x2, and x3. On the x-axis, you can choose any point with an integer coordinate a. On the x-axis, note that point A may coincide with x1, x2, or x3. Let f of a be the total distance from the given point to the point A. Find the smallest value of f of a. Okay, so basically what we want to do in here is that we have 3 points like this. Let me make it bigger. We have 3 points like this: x1, x2, and x3. We want to choose a point like A so that the sum of distances from A will be minimized. But it can be shown that it is the best if we choose it as the middle point. If, for example, if we sort these 3 points, let me move it to the center. If we choose the middle point as our point A, our answer is going to be the maximum minus minimum. And this is the minimum value for this answer. I mean, the answer cannot be less than this. Because wherever A will be, I mean, you have x1 and x3 in these 2 points. Wherever A is, the sum of distances from A to x1 plus the distance from A to x3, assume that I've sorted them. They are in the sorted order now. This sum is always greater than or equal to the distance between x3 and x1. So the answer is at least this much. The answer is always at least this much. And which, if we choose the middle point as this value, that is gonna be the answer that we're gonna have. I mean, we're gonna have this. So we showed that it cannot be better than this. And also we showed that this is achievable. So this is gonna be our final answer. And if we see my code in here, it's just simply getting three numbers and just see out maximum minus minimum. Is it clear? Let's maybe switch to. Shall we move on to the next problem? So for the first problem, it's just simply the maximum of the numbers minus the minimum of them. Okay. So if you are okay with that, give me this emoji. This 100 emoji. Okay. So I guess you're okay with it now. So let's move on to problem B then. Okay, so you are given a matrix of size n by m where the rows are numbered from 1 to n from top to bottom and the columns are numbered from 1 to n from left to right. The elements at the intersection of the ith row and the jth column is denoted by a of I sub I and j. Consider the algorithm for stabilizing matrix A. Find the cell ij such that its value is strictly greater than the values of all neighboring cells. If there is no such cell, terminate the algorithm. And just each time when we choose one of these, one of these cells with this situation, we subtract that number by 1. And we need to say that what the matrix will be at the end. Okay, so basically what we are going to do in this problem is that we are trying to, each time we have this matrix, each time we choose a cell that is greater than all of the neighbor cells, and the neighbor cells are all the ones that share at least one side with it. Okay, so they should share a side. I mean, they should share exactly a side. And if it is strictly greater than them, we subtract that number by 1. And we should say that what is going to be the answer at the end. It is easy to say that if a number initially is not strictly greater than all of the neighbors, it never will be. So if a number initially is not strictly greater than all the other numbers, it never will be. It's not possible to make, if it has a neighbor, for example, we have this cell and this neighbor y is greater than or equal to x. It always remains greater than or equal to x. It never, we will never have y less than x. We never subtract y to make it less than its neighbors. So it always remain greater than or equal to x. So x will never be decreased. So what would say, I'm not Indian. I'm not Arabic as well now. Yeah, I'm Iranian. I'm Persian. Yeah. So what we can say is that a number, if initially a number is not greater than all the neighbors, it will never be subtracted at all. Okay, but if it is, when it's gonna end up when it is equal to at least one of its neighbors. So it's only enough that for each of the cells we find all of the neighbors. I mean, for each cell we consider its neighbors and we see that what is the maximum value of them. And we just say that, for example, if this cell is x and the minimum value of all the neighbors are, for example, like z, we just need to say that x should be turned into minimum of x and z. Sorry for this noise, by the way. So that's gonna be all for this problem. So for each cell you need to just consider all of the neighbors, and then we're gonna say that this value should be minimized with the maximum of those numbers, and that's gonna be all. Is it clear? If it is, we'll move on to the code. If you're okay, again, use the emoji, this emoji. Okay. So let's move on to the code. In here, in problem C, oh sorry, problem B, it was B. In problem B, I just simply save these values to check all the adjacent cells, and then I simply just say that I have a 4 on n and m, I've seen everything, and each time I have at most 4 neighbors. I just have a 4 and ni is gonna be I plus dx of k. This is how I use dx and dy. For example, the first neighbor has 1 less, you know, the value of its x is 1 less than the current one, but the value of y is the same. The second one, x is the same, 1 is 1 less, y is 1 less. The third one, x is 1 more, y is the same. So this is how I have a 4. This is the cleanest way to have a 4 on all the neighbors. It is way better than using several ifs. Okay, I have a 4 on all of them, and if it was inside, and inside is like this, I just say that I should be between 0 and n, and j should be between 0 and m. If it was inside, mx is equal to maximum of mx and a of ni and aj, because I want to calculate the maximum value of the neighbors. Then I say that a of I and j is equal to minimum of a of I and j and mx. Is it clear? So this is basically what I was doing here. I had this value of z, this value of z, and I was just calculating the maximum of these 3 values, and then I was saying that, okay, this value should be minimized with the maximum of those values. Is this one clear as well? Yeah, sure. Yeah, sure. I will explain dx parts again. Well, basically, what do you do when in a grid, you have a grid? Sorry. You have a grid like this, and you are on a cell, and you want to find all the neighbors of a cell. A way that you can do that is to just simply have several ifs, for example, and just consider all of them separately. That's one thing that you can do, but a better way is to define 2 arrays, each of size 4. For example, dx is like this, -1, 0, +1, 0. And dy is like this, 0, -1, 0, +1. So this gives me the coordinates of the neighbors. You know, if I have a cell x and y, the neighbor number I of them is gonna be x plus dx of I and y plus dy of I. This is how I can have a 4 on all the neighbors. I can have a 4 I from 0 to 3, 0, 1, 2, 3, and consider the cell. I can say that nx is equal to x plus dx of I, and ny is equal to y plus dy of I. And this way, if I do this, then I can have a 4 on all the neighbors. And this is the cleanest way to do that. This is way better than just considering each of them separately. That way your code will be messy. But this way you can just simply have a 4 on all of them. It's just enough to define this. And each time you just need to also check that if it is inside, if nx and ny is inside. And as you can see in my code here, you can easily see that in is a very simple thing. It just checks if some coordinates are inside and just each time I have a 4 and I calculate these coordinates and I say that if it was inside, mx is equal to maximum of mx and this value, and then I say that a of I and j is equal to minimum of a of I and j and mx. Okay, is it clear? Sorry, let me... Awesome. So I think now we can move on to the third problem, problem C. Update queries. It says that let's consider the following problem. You are given a string S of length n. Let me first remember myself. Okay. So in this problem you had a list of indices. So initially you have a string. Let me explain it to you on tablets. So in this problem you're gonna have a string A and you had a list of indices and a list of characters that was also given to you as a string, like C. So you can rearrange indices and these characters. The length of indices is m. The length of this string is also m. Sorry. And you can just rearrange all the indices and you can rearrange all the characters in C and then have a for on all the indices and change that specific index with that specific character. Okay, so each time you can have a for on all the indices and just change that index with that corresponding character. So you have m indices and m characters and you can easily change each one of them. And at the end you need to minimize, lexicographically minimize your final string. Okay. Well, the main idea in this problem is that the first thing that I say is that I want to sort string C. So the first thing that I say is that, okay, first let's sort the string C because it doesn't do any harm, because we also can rearrange indices. So it doesn't do any harm to change the order of C's, because then we can accordingly sort the indices as well. So first I say sort, and strings can be sorted as well using the sort function of C++. We can just say sort C.begin, C.end, because I want to know the characters I have. First I want to know what are the characters I have. I want the best characters to be at the beginning and the worst characters to be at the end. The first characters are more valuable for me. The characters that come the first are more variable for me. So what do I want to do? The best thing for me is to just try to give those best characters to the first indices. I have several indices here. I have, let me show it on string A. For example, this is my string A. I have several indices that I can change, and I have, for example, my string C is also A, B, X, Z, for example. You know, it's the best to give A to this one, B to this one, X to this one, and Z to this one. So it's always best to give the characters first to the first elements. They have more priority. Okay, so if all the indices were the same, if all the indices were completely the same, it was just enough to sort string C and sort all the indices and then give the characters to those indices one by one. So it was that simple if all the indices were the same, were different, sorry, if no two indices were the same. But if indices can be the same, for example, the same index comes twice, for example, m is equal to 5 and this index comes twice. Well, the point is the first time that we change its value does not matter at all, because we're gonna change it later again. So the first time that we change it does not matter. So what can we say? We can easily say that the first time that we want to change its value, we can just give the worst character to it, because it doesn't matter, right? So if I want to change my source a little bit, I have these indices, I want to sort them in a good way. I just say that instead of just sorting them by their indices, try to source them first. Try to find out what is how many times this index has appeared in the list. Okay, for example, this one has appeared twice, this one has appeared once, this one once, this one once. M is equal to 5, for example. Well, I want the second time that it appears to be have the worst character. So I can just make a pair of each one. I can enumerate all of these indices. For example, if we have two of them, we can assign number 1 to the first time that we see it and assign number 2 to the second time that we see it. And then make a pair out of it. So for example, for each index of I, we also consider a CNT of index of I. It means that how many times I have seen this value. Each time I increase this value by 1. So it just keeps that how many times I've seen this value. And then I can just sort everything by pair of CNT of IND of I and IND of I. I can store this value and sort them by this. This way, the second time I see it, that goes to the end, because its first value is 2, not 1 anymore. And it will be given the worst character. So everything gets better when I show you my code as well. So let me explain more using my code. So let's consider this code. Let's take a look at it. Well, the only thing I do is this. I seen indices, and P of I is gonna be CNT of IND of I plus plus and IND of I. It's gonna be this pair, CNT of IND of I, and this plus plus means that's first store this value and then increase this value by 1. And IND of I, this way I can not only keep that what is this index, but also I can keep that for this specific index how many times I've seen this before, so that for the second time and third time and fourth time that I see it, they will go to the end. They will go after the first appearance of all the characters. And then I sort P and I sort C and I start from the end and I change the characters. Why do I start from the end? Because, the operation that I do the last is the most important one. For example, if I do many times, I do change some index, the last time matters the most. So I want the last time that I change this character to be the one that has the best character, to be the first appearance of it. If you remember, we sorted them by the number of their appearances till there and their index. And when I source these values and I start from the end and go there, when I reach its first appearance, it gets its real value. And at the end, I just see out A. Is it clear? I know that it might have been got a little bit complicated, but yes, this video will be available as a video later on, and this is gonna be uploaded to Codeforces as well. It is also gonna be in Codeforces editorial. So we're gonna announce that soon. Okay, so is it clear? If you are okay with that, again, use this emoji. Otherwise, tell me to explain it again. I have a question somewhat off topic. Well, maybe it's better to discuss these at the end. Maybe. Okay. Let's move on to the next problem. Okay. So, the next problem, mathematical problem. Okay. This is a problem that we have a string of n digits, and we want to put n minus 2 symbols of plus and product between them. At the end, we want to minimize the final number. We want to somehow put them in here to minimize the numbers at the end. So, we have a list of n digits. We want to put n minus 2. So it means that there is only one place. There's only one place that we don't put anything in it, right? Because there are n minus 1 spaces between these, and there is gonna be only one place there that we don't put anything. So it means that at the end, I'm gonna have exactly one number. Exactly one number with 2 digits, and the rest will have 1 digit exactly, right? So I will have exactly one number with 2 digits, and the rest of them will have 1 digit, because we're gonna change put n minus 2 symbols between them. So, and we know that n, the length of the string, is up to 20. It's so small. So we can simply fix that. Okay, where is that number that is going to have 2 digits? It's a simple brute force. So this is our number. We can just simply consider that where is going to be that number with 2 digits. This is my number with 2 digits. The rest of them will have exactly 1 digit. And then we can simply just say that we have all these numbers. If at least one of them is 0, then the answer is 0, because we can put product between each 2 consecutive characters, and the final answer will be 0. If there is no 0, the answer is going to be non-zero there. And if we have a 1, it's better to put products into, it's better to, we can ignore that one at all. It's the best to say it like, put it like this. So if I have any 1, I can ignore that one, because it can simply be multiplied by a number to the next of it, and it will have no effect. It can have no positive effect and no negative effect, so we can just ignore it. And the rest of the numbers, it's better to be added together. So the answer then is gonna be the sum of numbers, greater than or greater than 1. If we have a 0, the answer is gonna be 0. If we don't have any 0, it's gonna be sum of all the numbers greater than 1. In a special case that all the numbers are 1, then the answer is gonna be 1. If all the numbers were 1, then the answer is 1. So that's gonna be it. So we just can fix where is going to be that 2-digit number, and then we can just say that we have several numbers. One of them has 2 digits, the rest have 1 digit, and if we had any 0, the answer is gonna be 0. If all the numbers were 1, the answer is gonna be 1. Otherwise, the answer is gonna be the sum of numbers greater than 1. How it is 1? In the case that all of the numbers are 1, if all of the numbers are 1, we can just multiply them together, and the answer is going to be 1. And the answer cannot be less than 1 as well, so it is going to be the minimum possible value. Between the numbers, as I said, if at least one number is 0, then the answer is going to be 0, because we can multiply everything together. If all the numbers were 1, again we multiply all of them together and the answer is going to be 1. Otherwise, we just ignore the ones, because ones can be simply multiplied by the numbers to the next of themselves and they have no effect. For example, multiply each one with the number to the left of it, or with the number to the right of it if no number was to the left. And then when we did that, we can just see we have several numbers, all of them are greater than 1, and then it's the best to sum them up. It doesn't make sense to multiply them anymore, because by summing up, when you have two values, both of them are greater than 1, you have x and you have y, x and y are both greater than 1. Then you can simply say that x times y is greater than x plus y. Why? Because without loss of generality, assume that y is greater than or equal to x. This number is gonna be at most 2x, but this number is gonna be at least 2x. It was better to say greater than or equal to. Okay, so when you have two numbers, both of them are greater than or equal to 2, the sum of them is less than or equal to the product of them. Why? Because the sum of them is less than or equal to, 2y, I meant 2y. Y was greater than x, I'm sorry. X plus y is less than or equal to 2y, x times y is greater than or equal to 2y. No. I think you didn't consider some part. I said that first I split the numbers. So I assume that the first thing I do is to choose that where I want to have two digits. For example, if the input is this, if the input is 1, 1, 1, 1. For example, one case is to choose these two numbers together, these two digits together, and these numbers as single digit numbers. Then we don't have 4 ones. Then we have a 1, an 11, and a 1. So all our numbers are not 1 anymore. For example, in this case, all our numbers is gonna be 1. For example, we match these two numbers and these ones. Then we have 3 ones. Okay, so first thing that I did was this. The first thing that I did, I said that I will fix the two digits that will be matched together, and then I will consider those numbers. One of them has 2 digits, the rest of them have 1 digit, are single digit, and then I consider the numbers. For example, in this 2-digit number can be, for example, 93, can be 1, can be anything. So I first fix that because I said n is up to 20. Okay. Yes. That is correct. 1, 0, 1, 1. The best answer is 0. Yes. So I was just telling you the example that all the numbers is gonna be 1. I didn't say it's the best case. For example, for 1, 0, 1, 1, if you just split the numbers like this, you're gonna have a 1, a 0, and an 11, and you have a 0 there. And the answer is going to be 0 there. But I wanted to give you an example that when, for example, all the numbers can be 1. Okay, so I consider all these cases. I do not only consider the case that I match these two numbers. I said that I consider the case that these two numbers will be a number, these two digits will be a number, these two digits will be a number, and these two digits will be a number. So there are n-1 choices for this. And for each choice, we have exactly one number with 2 digits and n-2 numbers with 1 digit. Okay. And then between those numbers, if I had any 0, my final answer is going to be 0. If I didn't have any 0, and all my numbers, all the remaining numbers, including that 2-digit number, all of them were 1, the answer is going to be 1. Otherwise, the answer is going to be the sum of numbers greater than 1. Does it make sense now? Or do you have still any question? What if the sequence is like 1, 1, 2, 3, 1? 1, 1, 2, 3, 1. we have to take multiply sign before 2 to minimize. Again, in this example, we need to first consider all the cases to split them. For example, we have these two together, for example, this, and this. For example, if we split them like this, we have to consider all the cases. We brute force over all the cases to match two digits. Then I just say that for these numbers, for example, if it is 11, 2, 3, and 1, as I said, the answer is going to be the sum of numbers greater than or equal to 1. Greater than 1. So it's going to be 11 plus 2 plus 3 in this case, plus 3 in this case, which is going to be 16. If I match these two, I'm going to have a 12, a 1, a 1, and a 3. So it's going to be 12 plus 3, it's going to be 15. If I match these two, for example, I'm going to have a 1, a 23, a 1. So it's going to be 23. And if I match these two, it's going to be a 31, a 2, a 1, a 1. So it's going to be 62. 31 times 2. 31 plus 2. It's going to be, it's going to be 2 plus 31. 33. So this is going to be all. So it's just enough to say that we brute force. We said that there is only one number that has 2 digits and the rest of the numbers have only 1 digit. It's just enough to find out, do a brute force and find out where we have a number with 2 consecutive digits. So we have a brute force for that. Then we have one number with 2 digits and n minus 2 numbers with a single digit. Then we consider those numbers. If any of them was 0, the answer is 0. If at least one, if all of them were 1, the answer is gonna be 1. If it was none of these two cases, it's gonna be the sum of the numbers greater than 1. So I think it can make more sense now if I also show you the code. Show you my code. This is my code. I just first fix that where I want to have those 2 digit number. That's 2 digit number. So I first fix there. It can start from 0 and it can start from n minus 1. And then each time if I was equal to that start, my number is going to be 10 times this character plus the next character, otherwise this number is going to be this character itself. And I just add 1 to I here to jump the next character. And then again I have a 4 on CNT. CNT is equal to n minus 1 always. I say that if a of I was 0, val is equal to minus 1. Val equal to minus 1 is a sign for myself to know that the answer is 0. Okay, val equal to minus 1 is a sign for myself to know that the answer is going to be 0. And you can see that in here I said that if val was equal to minus 1, it means that val is 0. Answer is 0. So val is equal to minus 1. If a of I was equal to 1, ignore it, continue, otherwise add ai to val. At the end, if val was 0, then I should make val equal to 1, because it means that first of all we didn't have any 0 and also we didn't have anything greater than 1. So all the numbers were 1. So the answer is going to be 1. If val was equal to minus 1, it means that we had a 0, so the val should be 0. And at the end we have this val. It's enough to say that ans is equal to minimum of ans and val, because for each of these cases, for this starts, we need to find out this val and find the minimum value of ans for that. Is it clear now? Let's me. Does it make sense? If you're okay with that, please again use this emoji. Awesome. I don't know what, yeah, maybe 20 was very small. They could also put n greater and say that the sum of the values of n are greater, but I think that wouldn't make any big differences, so it was okay. But yes, maybe when people see n is up to 20, they start to think about bit mask, etc. But it was not related to that. Yes, D is done now. Okay, so shall we move on to problem E? Okay, let's move on to problem E. Okay, this says that you are given an array of integers a1, a2 to an and an integer k. You need to make it beautiful with the least amounts of operations. Before applying operations, you can shuffle the array elements as you like. For one operation, you can do the following. Choose an index and increase it by k. You want to make it palindrome. You have this array, you say that it is beautiful if it is palindrome. If b of I is equal to b of n minus I plus 1. Find the minimum number of operations needed to make the array beautiful, or reports that it is impossible. Okay, so we have this array b1, b2 to bn beautiful if it is palindrome, if the numbers are, the first number is equal to the last number and so on. You have now, you are given array a1 to an, and each time you can choose one of the elements and increase it by k. You can choose some I and increase a of I by k. Okay, so well, the first thing that I can say is that if two numbers are going to be equal to each other at the ends, they should be equal modulo k. So if I want to make a sub I equal to a sub j, initially they should be equal modulo k. Otherwise, because I cannot change the numbers modulo k, by increasing them by k, I cannot change them modulo k. So I want to somehow sort all the numbers in A. I want to somehow sort them so that first, all the numbers with having the same remainder over k be next to each other, and be among themselves, they will be in the sorted order. So I want to write a CMP function that can sort this array and puts all the equal numbers next to each other, all the numbers that modulo k are equal next to each other, and among themselves sorts them in ascending order. So the first thing is to just write this sort function. So let me show you. I have a sort function, CMP function I mean, that I give to my sort. I say that if I modulo k was equal to j modulo k, return I less than j, otherwise return I modulo k less than j modulo k. Well, what this function does is that it gets, whenever it gets two numbers, when it wants to compare them and say that which one should come before the other one, for example, you have I and j, you will return 1 if you want to I to come before j, and you will return 0 if you want j to come before I. I say that what is the condition that I comes before j? One case is that they are same modulo k and I is less than j. The other case is that they are not the same modulo k and I modulo k is less than j modulo k. This way, when I sort my array, all of the numbers with the same remainder over k are gonna be next to each other and they will be in the sorted order. Okay, is everything clear so far? Are you all okay with this CMP function, or does anyone need more information about this part? So till now I have like this, my numbers are partitioned like this. For example, this is these numbers have remainder 0, these ones have 1, and for example this one is k minus 1. Okay, awesome. So this is how I will sort the numbers, and then in each block there are two cases. Either the size of the block is odd or it's even. If it is even, it's good. I mean, I like them to be even. Why? Because if they are even, each time I can put one of them at the beginning, one of them at the end, and remove both. I mean, each time I can put one to the beginning, one to the end, and make them equal to each other. Okay, so that's a good news if we have even number of them. But if we have odd, the issue is that one of them will remain. I can match them one by one. I mean, each time I can take two of them and match them with each other, but at the end one will remain. One of them will be remains, and that's gonna be an issue, because how can we match that one? The point is, if there is odd numbers, I mean from a remainder, I have odd occurrences of that one, I have to put one of them exactly in the middle of my final array, such that it won't be matched with anything. It only can happen if I have only one number. By numbers I mean these values, that's values of remainders. I have exactly one remainder that I have odd occurrences of it. If I have two remainders that both had odd occurrences, on one hand I should put one of these ones in the middle, on the other hand I should put one of these ones in the middle, because none of these two, there is at least one element from here and there is at least one element from here that cannot be matched with anything else. They can only be matched with themselves. So I should put both in the middle, and that is a contradiction, because when the length of my array is odd, the good news is that there is one element exactly in the middle, and for this one I have no constraints. I do not need to make it equal to anything. I have no constraints for this one. So this middle one, you know, when the length is odd, this middle one can be anything it wants. And if I have odd occurrences of some specific remainder, I can put one of them in the middle. So this shows that there should be at most one remainder that I have odd occurrences of it. Because if I have two, both of them need this middle point, but they cannot both using it. Okay, they cannot both use it. So what I can say is that in this case I can put only one in the middle, but if I saw two remainders with odd occurrences, the answer is definitely -1. There's no way anymore. And for the even ones, again, if we go back to the even ones and see that how much do they contribute to our final answer, for the even ones I have them in the sorted order. It is the best to match them, match the first two, then the next two, then the next two, because it's the best. If I consider the minimum number, it's best to be matched with the second minimum. I need the minimum number of operations they are the closest to each other. I mean the minimum value is the closest, the closest value to it is the second minimum. It's better to match these two. So it's like I had even points, even number of points. For example, in here I have 8 points. The best way to match them is that to match these two, these two, these two, and these two. This way the sum of the differences will be minimized. Okay, because I have to sum up these values of differences, and I should divide them by k, because each time I can increase the value by k. Each time I can increase the value that is less than the other one by k. It's the best to match them 2 by 2 like this. But if it is odd, and as I said, there can be only one remainder with odd occurrences. If I saw that two of them have odd occurrences, I said that the answer is impossible. There's no way. But if there was only one, I fixed the position of that one that wants to be in the middle. For example, assume that, how many do I have here? For example, 9. I have 9 numbers in here. For example, if I choose this one as the one that will go to the middle of my string, middle of my final array, then I have to match these two and these two and these two and these two, because the rest are even and they can easily be matched to each other. So this problem is similar to a prefix sum and suffix sum. I mean, it's like for each cell you need to know that what is the sum of this prefix if I match them, if I match each two consecutive ones, and what is the sum of this suffix if I match each two consecutive ones. And then I just add these two values and minimize the sum of these two. So it's like I know odd positions, I need to choose one, remove it, and to the left of it match them 2 by 2, and it's easy to show that on both sides there should be even numbers. I mean, it's easy to show that in both sides it makes sense to have even numbers. If for example you choose this one, it doesn't make sense. If you choose this one as your middle one, it doesn't make sense, because then you have to match these two, but it was better to choose the third one and match these two instead. Do you see what I'm talking about? So it doesn't make sense to choose someone that on each side you're gonna have odd numbers. It doesn't make sense. You will always choose a number that on each side there will be even numbers and you can match them 2 by 2. Because otherwise, if on each side there are odd numbers, you should match the last one of these with the first one of these. But it was better to match this one that you have with this, and for example remove the previous one. So it's easy to show that that's not optimal. So it's just enough to have this prefix sum and suffix sum and just add these values and take the minimum of them. And that's going to be our final answer. Is it completely clear? Please put a plus if it completely makes sense. Or use this emoji. Whatever. Okay, awesome. So I think this problem is also okay. Let's move on to problem F. Okay. So, non-academic problem. You are given a connected and directed graph, the vertices of which are numbered with integers from 1 to n. Your task is to minimize the number of pair of vertices between which there exists a path in this graph. To achieve this, you can remove exactly one edge from the graph. Okay, so you want to remove one edge from your graph so that you will minimize the number of pairs of vertices that have a path to each other. This is a very classic problem. Show my code. Do you need me to show my code for problem E as well? I can show you my codes, by the way. This is my code for problem E. For the rest of it, I showed you this CMP part. For the rest of it, I just find that interval. I just find that specific interval, and I just say that this is my prefixes. If the number of elements was odd, first I see that my flag becomes true when I see at least one odd occurrences. If flag is already true, it means that I have seen another odd. So ans is -1 and break. Otherwise, I will set flag true here to true here. And I have pref of L, suff of L, and I just calculate prefixes of suffixes, and I find minimum of the sum of prefix and suffix. Otherwise, it's easier for me if they are even. I can have a 4 and sum the values up. Is it clear now? So this was the code. Okay. So, okay, let's get back to the problem F again. Problem F. So, problem F states that you have a graph. It is not necessarily connected. You can remove one edge so that you will minimize the number of pairs that have a path to each other. Well, this is a classic problem, and let me also say that n is up to 10 to the 5th. This is a classic problem. It's just stating that, well, first of all, it's easy to show that if removing an edge is gonna help us, if it is going to reduce the number of vertices, the number of pairs of vertices that have a path to each other, then necessarily this should be a bridge. What does a bridge say? I mean, what is a bridge? A bridge is an edge that if you remove it from a connected graph, that graph will be disconnected. Okay, so consider one of those connected subgraphs that you have. It means that if you consider that connected subgraph, by removing that edge, that connected subgraph is not connected anymore. So this is the only way that we can reduce the number of pair of vertices that have a path to each other. So the first thing that we say is this: we need to find bridges, otherwise the answer wouldn't be changed. So also we need to say that we can find the answer independently. We can find the answer independently for each connected component. So we might have several connected components, and for each one of them we should find the best bridge that we can remove. For each one of them we can find the best bridge that we can remove and find the maximum of them over all of the subtrees. So in each one I find the best bridge and I find the best one of them and subtract that from the current number of pair of vertices that I can have. Okay, so I can say that initially I can just have a 4 on all the vertices, and if it is not visited yet, I will start a DFS from there. I keep the height of each vertex, the size of subtree of each vertex. It means that when I do DFS, how many vertices I see from the inside the DFS of this vertex. And I also need to have a DP for this vertex. That means that if I consider all the back edges, we know that DFS only has back edges. It does not have any cross edge. It means that all the edges other than the tree are from a vertex to one of its ancestors. So between all of the back edges from this subtree, we need to find out what is the minimum heights that we can go to. So for example, if this is vertex V, if this is parent of V, for example vertex P, we need to find out between all these back edges, where is the upmost one, where is the one that goes to the upmost vertex, to the vertex with the least possible heights. I need to find that out. Okay, and that can be easily be found out. It's just for each vertex I need to first, when I have a 4 on all of its adjacent vertices, when I see a vertex that is outside of its subtree, is to an ancestor, is to an already visited vertex, I just say that and it is not its parent, because we should not consider the edge to the parent, because that's part of the tree and that's the edge that we want to remove. We want to consider that if we remove this edge, is there any edge from this subtree to outside or not? So we should not consider the edge to its parents itself. So between all those edges, I consider the minimum possible heights to the vertex that I can go to. And also when I run the DFS of the children, I say that, for example, for vertex U, when I run DFS of U, I say that DP of V will be mean equal to DP of U. So it will be minimized with the value of DP of U. Okay. So because if the subtree of vertex U has an edge to something, subtree of V has the edge to the same thing as well. So that should be considered in V as well. And at the end, if DP of V was less than height of V, it means that the edge from V to its parent is not a bridge, because by removing it there is still one edge from the subtree of V to the outside, so that vertex is not an edge. This is not a bridge anymore. But if dp of v was greater than or equal to h of v, it means that if you remove that edge from v to its parents, there's no way anymore that we can go from its subtree to the outside. So that is a bridge. Okay, so this way we can find all the bridges, and at the end we can find what is the size of the subtree of this vertex and what is the total sum of the size of the subtree of this connected graph at all, and we can easily find out how many pair of vertices will be removed. It's gonna be the number in here. For example, if the total number of vertices is, for example, TOT, size of subtree of v is size of v, then by removing that bridge, the number of pair of vertices will be decreased by size of v times total minus size of, and that's going to be all. So we need to maximize this value between all the bridges. We will find the best value for this, and at the end we will subtract that from the initial number of pairs that we have. And what is the initial number of pairs that we have for each connected component? If we have this TOT value, total value, I should first consider this value, tot choose 2, because that's the initial value of the number of pairs that have a path to each other. And this way we can just, at the end, if we find the maximum of these values, we can subtract that and find the final answer this way. Yes, you're right. It is given that the graph is connected. That makes it even simpler. Yeah. So it's only one connected subgraph. Yeah, I explained for the case that it can be disconnected, and then you have to do this for each connected component. But yes, you're right. It is initially connected, so it's even easier than that. We can just do this on the main components that we have. I didn't see that slide. Yeah. So is this one clear as well? Any resource that you can learn about bridges? I'm not sure at the moment, but maybe I can make a video for that very soon. If that's gonna be helpful, maybe I will make a video and solve several problems for that. Yes, bridges are common, and this problem was some sort of a classic problem. Yes, CP algorithms, and now that I remember, Yusaku Guide might also have it. I haven't checked Yusaku Guide myself, but Yusaku Guide also might have explained this. Okay. So, shall we move on to the next problem? Let me also show you my code first. This is my code. It's just very simple. I just each time, well, I assume that it can also be disconnected, so I just have a for, and if it was not visited, I just add to sum this value, and then I have all the candidates. What are the candidates? Candidates are the one that dp of v is greater or equal to h of v. It means that their h to their parents is a bridge. And then between all those candidates, I say that best edge, the best value that I can have from an edge, will be equal to maximum of itself and size of the subtree of v times size of the subtree of I, which is the root of this subgraph, this connected subgraph, minus size of v, size of the subtree of v. And at the end, I just see out sum minus best edge. Is it clear? So this is going to be all for problem E. Shall we move on to problem F, sorry. Shall we move on to problem G1 and G2? For problem G2, there's something that I myself want to know as well. I will tell you about it. I should see how others solved it as well. Okay, so shall we move on to problem G? It's somehow similar to that. Yes, it's similar to that. Because in Tarjan also we're talking about two connectivity, and that's gonna be the same. We're saying that when sometimes we want to check if a vertex will be removed, everything will be connected again or not. And sometimes we want to talk about the edges, that if you remove them, everything will be connected or not. So, yeah, so let's move on to the next problem, problem F. Well, about, problem G, G1 and G2. About this problem, I have to say something that I myself, honestly, assuming that G2 will not be accepted with my code, because otherwise I didn't understand what was the point of G1. But I just submitted it and I saw that it got accepted. I'm not sure if that's the main solution of that one, and that's why I wanted to check the codes of others as well. But it seems like, yeah, from what I see on their codes, it seems like they also have used the same idea. From what I see, it seems like they also have 3/4, the codes that I checked. So maybe we can start talking about it. The problem says that you are given a permutation P of length n, calculate the number of index pairs I and j such that Pi times Pj is divisible by I times j without remainder. So basically we have this permutation. Let me also write it formally in here as well. We want to count the number of I and j's such that Pi times Pj is divisible by I times j. Well, first of all, what I do is this. I just make two values, ai and bi, for each I. Well, ai, let me tell you the informal definition of them. ai is the value that this element gives you. That this element gives. Bi is the value that this element gets. What does it mean? I mean, first I told you the informal definition of it. It means that, you know, when you have, for example, two numbers, for example, one of them is 6, one of them is 9. Okay, it means that I mean that, for example, P of I is 6, but I itself is 9. What does it give? What does it get? Well, in here, they have their GCD, the GCD of Pi and I is 3. So first of all, they both have a 3 that can be cancelled with each other. It doesn't matter at all. There's a 3 that they cover each other's 3. So I can say that what remains from P of I will be 2, what remains from I will be 3. So I say that A of I is 2 and B of I is 3. What does it mean? It means that whenever it will be matched with something like J, A of J and B of J, A of J should give it a 3. Because it needs a 3 and it doesn't have at the moment. So A of J should give it a 3. But also this one has an additional 2 that can give to B of J. So it's like each number gives you something and gets something from you. For example, if this is 6 and 9, it gives you 2 and gets 3. So a of j should be a multiple of 3. Also, a of I should be a multiple, 2 should be a multiple of b of j. So they should cover each other needs. Each one of them can give something and they need to get something. And you need to see that for how many pairs they can be matched to each other and satisfy their the other one's needs. Okay, is it clear? Is this definition for a of I and b of I clear? So basically the whole thing that we want to say here is to say that each number has some value that it gives and some value that it gets. If you are okay with that, put a plus or the emoji of this emoji. So that's the first thing that I say. So now I have pairs of numbers. I have pairs of numbers AI and BI, and it means that I have a list of pairs, and it means that for each of them I have several elements, each one of them gives something, gets something. And if they can cover each other, if for example I have two people such that both J can satisfy the needs of I and I can satisfy the needs of J, then they can be matched together. And I want to find the number of these pairs. Okay, so now how can I do that? Well, the first thing that I do is to find, well, first of all, calculating A of I and B of I is very easy. I just consider P of I and just divide both of them by their GCD. That's going to be all for calculating A sub I and B sub I. But after that, each time, you know, I know that I have some value of A of I and B of I for each one. I have a 4 on some value X, and I want to find all the values. I have a 4 on X, and I have to find the answers for all of the numbers such that B sub I is X. Okay, it's like I have a 4 of X, X goes from 1 to N. I want to find the answer for all of the numbers that need X. For example, this number needs 3. So it's going to be in, for example, vector of 3. So for each X, I want to find the answer of everything such that their value of B is X. They need X. So when they need X, first, I find all those elements that they need X, and I will store them. I store them. First, I find all of those values that their value is X, and I store them into an array. For example, in an array, I will store the value of A. So, for example, I have this value, and this value. These are all A sub, for example, this is AI1, A sub I1, A sub I2, A sub I3. They are all some indices such that their B is equal to X. I store these values in somewhere, and I will tell you how I will use it in future. So I will store all these values that their values of B is equal to X. Now I know that they should be matched. They should be matched with some J such that A sub J is a multiple of X. So I have another 4. I have another 4 on Y that starts from X and goes to N, and each time will be added by X. Okay, this is the sieve idea. That we know that these two 4s combined is going to be N log N, right? Because the second 4 will jump X by X, not 1 by 1. So I have the first 4 of size of X from 1 to N. The second 4 is going to jump x by x. So this is how it can move on. Okay, so I know that a of j should be equal to y. A of j should be equal to y. I have another vector for them, and I can just say that if I, maybe it's good to also show you my code in this part, but anyway, I just consider all those values, I just consider all these j's such that a of j is equal to y. Okay, so I consider all the j's such that a sub j is y. So if I want to repeat everything, I first fix x, the value that they're going to need. Then I will fix all the elements such that their value of b is x. They are going to need x. Then I will fix y, which is going to be the value that j is going to give them, which is going to start from x and go to n. And then I will have a for on all of the j's such that a of j is going to be y. For example, I have another vector that in it I will store that which elements have this value of a. I have that all the elements that their value of a is equal to y. Okay, so now that I have this, I know that in this array that I have stored already, I should find the number of multiples of b of j. You see what happened? I know that j covers the needs of I. J covers the needs of I because a of j is y and b of I is x and y is a multiple of x. b sub I is x, a sub j is y, and y is a multiple of x. So I know that j covers I. I haven't fixed I just fixed x. Okay, I haven't fixed the value of I have fixed x. I know that whatever, any elements like I, such that b sub I is x, is going to be covered by j. And then I need to find the number of i's in this array such that a sub that I will be a multiple of b of j, so that I will cover j as well. I know that j covers I, now I need to make sure I covers j as well. So for this value of b of j, for this value of b sub j, I will have a for on this array now. This is my third for that I'm gonna have. I have a for in here, and I will start again. I have another for L that starts from b sub j and goes to n. Each time will be added by b sub j, and it will add the CNTs of all these values. In each cell I know that how many of that values do I have. For example, I know that here I have one a of I1. For example, if a of I1 is 5, I increase CNT of 5 by 1. If this is 11, I increase CNT of 11 by 1. If this is 15, I increase the CNT of 15 by 1. So it's just enough to find out the sum of the CNTs of these multiples of b of j, and then I will find the number of suitable i's as well. And then I know that for that j, how many i's will be matched. And this way you can easily find all the pairs. At the end, you just need to subtract the condition that a number will be matched with itself. So if b of I was equal to 0 for some number, you should subtract the answer by 1 at the end. And then you should divide the answer by 2 because you have considered each pair twice. So this way you can find the answer. First, let's see if this is clear or not, and then we will try to find the time complexity of it. Is the statement clear? Is the solution clear without considering time complexity? Then we will try to find the time complexity. So again, If you are okay with the solution, use this emoji. Or if you need me to explain any part again, feel free to tell me. Okay, so I think there are no questions. So the main idea in here was to just store everything in vector of x in vector of b of itself, and then have a for on all the x's and find everything that needs x. Then keep an array and in which I store the number for each I increase the CNT of a sub I by 1, so that at the end I'm gonna use this. I'm gonna use this to count my answer. And then I will have a for on y, which is a multiple of x. I know that in total these two fors are going to be O of n squared. N log n, because this one jumps x by x. And then I will have a for on all of these indices like j. I find a sub j's. I know that each one of these numbers will be seen when I have a for x on a divisor of y. So in total they wouldn't be seen too many times, because do not forget that a sub j's were initially a permutation and then they were divided by GCDs. So in total it's going to be n log n till now, and then this is where I have the my third for, and this is where I have a for of L. I start from b of j, I go to n, I add them by b of j, and I will use this array that I stored in here. Okay, so then I can find the number of i's that will be matched with this j. So this way I can find the answer at the end. But what is the time complexity this way? Let me show you my code and let's find the time complexity of this. Well, in here I know that these numbers need x. As I said, I have it. First of all, I get all the numbers, I clear every vectors, etc. I calculate a sub I and b sub I divide them by GCD, and I store them into vectors. And then I find all the numbers that need x. I increase their CNT by 1. Then when I have a for on y, which is a multiple of x, I will see all the numbers that give y to you, and y is a multiple of x, so they satisfy the needs of all the numbers that need x. So I set val equal to b of I, and here is where I add another line, and I say that I know that for this val, maybe another number also had this val. Maybe there was also another number that also had this value. And for that value, I have already calculated the sum of these CNTs. So, I mean, I see that what was the last time that I have calculated the answer for this one. And if last of val was not equal to x, I will calculate it now. And I said that, okay, now the last time I calculated answer for val is x. Okay. And this way, at the end, I will add rest of val to ans. Why I do this? Because if two of them have the same value of b, it's not necessary to do it for both of them. It's just enough to do it once. But anyway, I know that these four still here are n log n. No, it's like I have another for this value of x. Well, okay, the main point is that for each val, I do this only once for each x. Okay. So, I mean, the thing that is happening in here is that for this val, initially, let me think that how can I put this. Yeah, cool. Okay, let me think that how can I put this. Well, in here I can just say that I have this val is equal to b sub I, and I want to find all the values that are a multiple of val. And I know that each number, okay, let me say it like this. I know that for each number, it is in one of these vectors. And how many times I will see it in these vectors? Equal to the number of divisors of y. I mean, whenever my x is a divisor of y, I will come to this I. Okay, and in there, when I come to this I will have a 4 on the multiples of b of I. And b of I itself was also a permutation at the beginning, and then it was divided by some GCDs. When we make sure that we don't calculate the same answer twice for them, again we're sure that we are considering all the values and finding their multiples only once. So in total, what I was assuming, and I still believe that it should be right, is that this should be n-log squared, not n-log. And that was why I was believing that it should pass G1, but it should not pass G2. But then I checked, I just submitted to G2 to test it, and I saw that it got accepted. And when I saw the codes of other people, it seems like they also did the same thing. For example, when you see here the codes of Dirimun, you can see that he also had these three fours. The first 4, the second one here, and the third one here. And I think that they also did the same thing, though I'm not sure. I should read that part to make sure that that is true. But anyway, I believe that this way it can be solved. If anyone here has another solution for it, feel free to say that. Maybe we can consider that one as well. And also, if your solution were the same as mine, you can say that as well. Do you have any questions or anything? Or any comments? Thank you. Again, if it is clear, you can use this emoji. I had MLE for G2 because of map, tried some optimizations on memory. After some time I got rid of map and it works. Awesome. So you solved all the problems? This is very cool. I see. Okay guys, how was the stream today? Was it better than the previous ones? This time I tried to make it better. I used these different scenes in order to make it better. I hope you enjoyed it, and also we are going to announce new solutions for Codeforces. These links will be included in Codeforces as well, in Codeforces editorial, and you can watch these videos from there as well. So, do you have any questions or anything? Awesome, thank you. It's great that you liked it. Okay, so I guess I'll see you next time. Yeah, what was your question? I forgot that what you wanted to ask. You're welcome. Thank you for watching. It was great. It's either trial and error. Yeah, you know what helps really? I mean, there's no magic that you need to do. It's, you know what you need to do is to just solve so many problems. I mean, that's the way that you can grow. I mean, try to solve so many problems, read the editorials, read the solutions. When you get more familiarized with the different solutions and with the different arguments, it's gonna be easier to you. You will feel more comfortable to come up with the logic. So there's no magic that you need to do in order to come up with logics. It's mostly about trying to find out a way to, you know, it's something that your mind should improve in it gradually. You cannot do it in one step. It should improve gradually. And how can it do that? By solving so many problems over a long period of time. So you should practice a lot over a long period of time, solve so many problems, etc. And then that is going to help you to improve in these senses. That's the main thing that you need to do. Yeah. Yeah, I recommend you, Cosmic Boy, I recommend you to participate in virtual contests. Virtual contests are very good. I remember that there were some periods of time that I was doing a lot of virtuals, and that was helping me a lot. Yeah. For 1250, I recommend you to solve 1200, 1300 the most. I mean, you can solve the other problems as well, but the most problems that you solve, I mean, you can solve some 1500, some 1400, some 1000 difficulty, but mostly I think it's good to solve around your own rating, because I think this is a more optimal approach. Because especially initially, you need to solve a lot of problems, and it's not very optimal to try to solve harder problems but solving a lot less problems. That's what I experienced myself, and I felt growth this way. And I think it's more optimal to solve around 1200 and 1300 for you to solve. Okay, I think, yeah, you're welcome. Thank you. Okay, so I will see you the next time, the next contest, hopefully. So yeah, you also should solve around 1000 difficulty, around 1000. Message me on Discord, maybe it's better, because CF has limits to answer the questions. You can also answer at most 2 questions daily, or in an hour, and 4 daily. So it has some limits and it's hard. So it's better to ask somewhere else, maybe on Instagram or LinkedIn or Discord. Choose one of those. Okay. So see you next time. Thank you for joining today. Goodbye for now.